Hey there, today we're going to be talking about proportional relationships, how to graph them, and how to identify if a graph or a table is proportional or not. So let's go ahead and look at an example. So it says that I have a boat and it's carrying containers that weigh 2,000 pounds each. Now, in order to fill out this table, what I need to be able to do is I need to be able to take how many containers there are and determine what the weight is. Well, if I take a step back and I know that one container gives me a weight of 2,000, I know that each additional container is going to be an additional 2,000 pounds. So that would be 2,000 plus 2,000 is 4,000. For three containers on the boat, it would be an additional plus 2,000 for a grand total of 6,000. And for 4 boats, another additional 2,000 gives me 8,000. Now, that's one way. I can just work forward by adding 2,000, adding 2,000, adding 2,000, and I could fill in my 2 lines of my table. And I could say that for 2 containers, okay, there's my 2 containers, it was a weight of 4,000. And for a weight for 4 containers, it's a weight of 8,000. Well, I don't always want to have to add 2,000, add 2,000, add 2,000. So we need an additional way of calculating. So notice that each time I'm not only just adding 2,000, but if I look from the input to the output, I'm also timesing by 2,000. So instead of calculating by adding 2,000, adding 2,000, adding 2,000, I can calculate the weight of a container by timesing the number of containers by the weight. So 9 times 2,000 is 18,000. And if I go back that just to test, notice 8,000 is 4 containers times 2,000, and the amount equals. So let's go ahead and fill that in, 18,000. And now let's go ahead and graph. So if I were to graph this, I notice that 2 is going to take me up to 4,000. Okay, and notice I'm looking at number of containers, which is where I line up the 2. And the weight over here is where I line up the weight. So for 4 containers, it's 8,000. And for 9 containers, it's 18,000. Now, one way to determine that something is proportional is to notice that the dots are in a kind of a consistent pattern, a straight line. So as I continue going forwards, okay, part of this graph tells me it's proportional because we're increasing at a consistent amount. I can also, and another important part about being proportional is that if I track that backwards, it tracks back through 0, 0. For 0 containers, the weight is 0. Let's go ahead and look at a table and see if we can determine if it's proportional or not. So my table is a little flipped. So instead of going X and then Y, we are X and then Y. But it's still asking me the same thing. It's asking me if I take this 1, okay, let's use our idea of timesing. Can I take my 1 and times by some number that's going to give me 9? Okay, take a second and think about that. 1 times what is 9? Okay, well, it's 9. If this is proportional, every time I multiply my next number by this 9, it should equal my output. So notice 2 times 9 is 18, which matches my output. 3 times 9 is 27, which matches my output. 4 times 9 is 36, which matches my output. So yes, this is proportional, and my y is 9 times my x value. Notice these were my x values, and I was timesing each of them by 9 to get my y. So let's try that again. So can I think of 3 times something that's going to give me 21? Okay, now some of you guys are probably already saying, oh, I know what it is. Okay, but let's suppose I don't know what that is. Maybe I'm not super comfortable with my times tables. You can always work backwards. Okay, to work backwards, take your y and divide it by your x. And if I take my y, so 21, and divide it by 3, it should tell me what I'm timesing by. And so I would type that in my calculator if I wasn't sure. 21 divided by 3 is 7. Okay, and that allows me to write that 3 times 7 is 21. So if I want to test if this is proportional, I need to test each and every single input XY pair to see if this holds true. So is 5 times 7 35? Yes. Is 7 times 7 an output of 49? Yes. Is 9 times 7 an output of 63? Yes. So again, this is proportional. And what am I timesing by my x each time? I'm timesing by 7. Okay. And this is proportional. I don't worry about that non-proportional. Let's go ahead and look at it, maybe a non-proportional one. Okay. And I'm just going to ignore this one right here. Let's say we look at this table right here, and I say, okay, 6 times something is equal to 12. Okay, well, what times 6 is equal to 12? Well, it's a 2. And again, if I wasn't sure, remember you can do y divided by your x. So 12 divided by 6 and see what that gives you. So there's my 2. That's how I found out that 2 if I wasn't sure. Okay, now in order to track and see if this works, I need to, if it is proportional, if I times 7 by 2 and if I times 8 by 2, it should give me this matching output. And I notice as I do 7 times 2 that that's 14 and 8 times 2 is 16. So this does not match this, and this, whoops, didn't mean to erase that, and this does not equal this. So I'm going to mark not proportional. So again, if what I'm timesing by, okay, on the first one doesn't match the second or the third, it can't be proportional. It has to go up by equal amount each time. Okay, notice if I did calculate what it was timesing by, this is timesing by 2, and this is timesing by 4, and this is timesing by 8. That's a different pattern. We want to make sure that it's the same each time. Whoops. So let's put this into real practice again. Okay, let's suppose that we are looking at some data and we're trying to figure out if something is proportional. Okay, so let's read this information. It says Susan trained 3 racehorses. She trained the first for 20 months. Okay, this is the 20 months, first horse. Okay, and I'm noticing 14 races won. The second for 60 months. So second horse, 60 races, 60 months trained, 42 races won. And for the third, she raced 90 months. She trained 90 months and she won 63 races. So I need to first write that as X and Y. Now, some tables are sideways. I prefer them up and down. Okay, if you'd like to write it if you'd like to write it like this, you can. Okay, but my X, okay, notice it's across the bottom, number of months trained. My X's are 20 months, 60 months, and 90 months. And the Y is the number of races won. So for 20 months, it was 14 races. For 60, it was 42. And for 90, it was 63. So if I wrote it this way, it'd be 20, 14 races won, 60, 42 races won, 90, 63 races won. Okay. And again, this is just 2 different ways to write the same thing. So if I want to determine if this is proportional, I'm starting to think, well, what times something is equal to 14? And I'm like, oh, dang it, I have no clue, because how is it going down if I times by something? So I'm going to work backwards. I'm going to do 14, which is my Y, and divide it by my X. So 14 divided by 20. And let's go ahead and take out a calculator. Okay, and I'm going to use the scientific calculator here on Desmos. And I'm going to do that division. So if I look back at my division, I am doing 14 divided by 20. So 14 divided by 20. And I get this nice decimal of 0.7. So what I've determined is that I'm timesing that first row by 0.7. So 20 times 0.7 equals 14. Now I just need to determine if I times 60 by 0.7 and if I times 90 by 0.7, if it gives me the values of interest. So 42, I want it to equal 42 and 63. So let's test that out. So 60, whoops, clear that. 60 times, what was my value? 0.7. And there's that 42. Okay, so yep, that matched. 42. And 90 times 0.7 is 63. So yes, this is proportional because I'm timesing by the same amount each time. Okay, and I can fill in this blank. The number of races of horse 1 is 0.7 times the number of months that the horse was trained. Let's look at one that is not proportional so you can kind of see the difference. Again, so Boris saw a magic trick online using magnetic marbles. He wants to buy a set of marbles so he can perform the trick. The marbles are sold in 3 different size sets. So with a set of 140 marbles, it costs 91. Okay, so X, Y, 140 marbles. Sorry, that looks a little scrunched. You can't read it much. 140 marbles and it's going to give me an output cost of 91. 180 marbles for 126 and 220 for 143. Now you can also kind of think about it as what am I paying for every single marble? Okay, that's what in the last example 0.7 was. They won 0.7 races. So in this case, I'm going to see if I can determine how much each marble is by taking my Y and dividing by my X and seeing if that pattern stays normal. So I'm going to test it always with my first one. So my Y, I'm writing this backwards, so I don't want to confuse you. My Y is 91. 91 divided by 140. And that's going to give me my cost of each marble. So 91 divided by 140 marbles is 65.65. So that's 65 cents per marble. So 0.65. So again, that's 140 times 0.65. That's a time sign. Is equal to $91. Now, if this holds true, 180 marbles times my 65 cents should give me 126, and we'll test that. So 180 times 0.65, and I notice that's 117, which does not match this 126. So it is not the same cost per marble. So in fact, in order to get 126, the price would have to be higher to get a higher price. So I'm just going to come down here and say that this is not proportional. I don't need to worry about filling in that sentence because it's not, and I move on ahead. So again, let's just do one more check of these tables. Okay, kind of use that same pattern. So if I want to know if it's proportional, I'm going to do Y divided by X to figure out what I'm timesing by, because I can't times 15 by a whole number get bigger. I probably can't guess that. So I'm going to do my Y, which is 3, divided by 15. Whoops, I got to clear all. 3 divided by 15. And I'm timesing by 0.2. So I think that I'm timesing by 0.2. I'm going to see if that's right. 20 times 0.2 is 4. So that's correct. That's also timesing by 0.2. And 7 times 0.2, clear all. 7 times 0.2. 7 times 0.2 is 1.4. So as I look at this, hey, that's 1.4. So this is not proportional. Okay. That is it. So for that one, we're going to skip this one right here. Sorry, one more example. That last one wasn't it. I want to know if I look at a graph, if something is proportional. So we already kind of talked about from our very first example, that one of the things to be proportional is the line needs to be straight, and both of these graphs are. So that's not going to help me determine if one's not proportional. But the other thing we need to determine is if it goes through 0, 0. If it goes through 0, 0, for sure it's proportional. Since this does not go through the 0, 0, we know for sure that this is not proportional. We don't even need to do our dividing trick, although we could if we needed to. But I still need to figure out how to calculate y. What am I timesing by x? So if I look at my dots, okay, 0, 0 is not super helpful, but this dot and this dot are going to help me figure out what I'm timesing my x by to get my y. So to take my x of 1, how am I getting 2? And to take my x of 2, how am I getting 4? What is it that I am timesing by? I'm timesing by 2. 1 times 2 is 2. 2 times 2 is 4. So I'm timesing by 2. And this time, that really is it. Thanks for all of your attention. And if you have any questions, please feel free to reach out.